Good afternoon. How are you all doing today? I can see so many of you have joined in. By the way, do you think the setup is a bit different today? What do you think? What's going to happen? Let's see. I can see Karthik, Nikita, Disha, Harsimran, Vrinda, Rudrakshi. Good afternoon, all of you. What do you think is going to happen today? Let's see how many of you have joined Telegram, because over there, the update was there. Hey Sunil, Venkat, Sonali, Geeta, Shweta, Stuti. Payal says experiments. Interesting. So it's going to be an amazing class. Home experiment, Sonali says. Good afternoon, all of you. Good afternoon. Thank you, Disha. Disha is saying perfectly audible, perfectly visible. Hey! So how many of you like experimenting? Let's see. Science experiments, chemistry experiments. Okay. Yes, you all are on the right track. Great. See, the ones who've joined Telegram, they already know about this session. And for the rest of you, quickly join it. Simran just loves science experiments. Good to know that. Hey Ajneesh, Karthik, Nikita. Yes, Dhruvi. Chemistry is your favorite. Good to know that. So today we will be performing some science chemistry based experiments. So let's do one thing. Let me show you my mini lab first. Are you excited to see the lab that we've set up for all of you over here? Yes? Alright, let's switch to the other screen and let me introduce the lab that I have over here. So, I hope you all can see this. We have so many things out there. So much for you. The setup looks amazing. Yes? Great. Some of you have started guessing the experiments. Good to know that. Chalo, फटाफट से एक green signal दे दो that everything is working fine. And then we get started. A lot of material, yeah. So this is my mini lab of my own over here, and you can create your mini lab at your home and perform all these amazing experiments. Yes, that's great. Hey, we've just started. We are not late. That's okay. Great, all of you. All right. If you're super excited, let's get started with the first experiment that we have for all of you. I can see the green signal. Yes, definitely. I can see a lot of you posting green signal. A lot of you telling me that everything is working fine. Great. Yes. See, I will not be able to take your name, all of you, right? Because there are so many of you live at this point of time. But yes, the good part is what's uniting us. That's chemistry. Love for chemistry and experiments. Good to see that. All right, let's switch to the second screen and get started with our very first experiment. Can you see this setup? I hope you can hear me also, and the setup is perfectly fine. All right, so what do we have over here? We have some transparent glasses. So you can take plastic glasses for this one. Yes? Yeah, so the name of this special experiment is walking water. Let's see how water walks. I mean, this is something really absurd, isn't it? So you need around 5 glasses over here. So 5 glasses, plastic glasses have been set up. Next, let's do one thing. I'll keep this over here right now. Let's add water to the alternate glasses. So, I'll start with the first one. Let's add water here. Really easy steps. And I'm sure you all will be able to perform this perfectly fine. So, I've put water in all the alternate glasses. Hey Adiraj, good to know that. So people are making guesses also what this experiment is all about. Alright, so we've put water in the alternate glasses. Yes, this is walking water. Let's see how it works. And now we have different food colors with us. So I'll start with the blue food color. Let me put some blue food color in this one. And let's just stir it. Let's make it perfectly blue. Great. I think any experiment that involves color is super interesting. Do you agree with me? In the next one, let me put some yellow color. Let's stir this one also. Yeah, colors make life interesting, isn't it? And in the third one, let's do one thing. Let's put the pink color. So I have the pink color with me and I'm adding this pink color to this. And I think all the steps are super easy. Do you agree with me? Do you also find all these steps super easy? Okay. Now once we are done with this, you can take out the stirrer. You've mixed it properly fine, right? So you can take this out and now what do you need? You need a paper towel. So this is how a paper towel looks like. Okay, you have to take this paper towel, fold it like this, fold it again like this, and then we have to insert in these glasses. So let's insert these paper towels like this. We're kind of making a bridge here. Yes, you can try this out, definitely. Great. Just make sure that they touch each other. So over here in the empty glasses, just make sure that the paper towels touch each other. The setup is almost done. I think the setup is super interesting, but the result is going to be much more interesting. And there you go. The setup is all done over here. Now let's switch to the main screen once. So we have a setup over here. Okay, we have to leave it for some time. So what I'll do is I'll start discussing rest of the experiments with you. Meanwhile, we'll notice what happens with this one. If you like this idea, because this takes some time, so we can definitely start with other experiments. But this setup is all set. So once I'm done with the fifth experiment, we can get this back. And once this is back, we'll see a wonderful result. Okay, any guesses? What do you think is going to happen here? Let me see if you can make the right guess or not. Let's see how many of you can make the right guess. Oh, you're trying. Okay. The name of this experiment was walking water. Yeah, walking water. We have to see how this water works actually. Color would travel, okay. But we call this something in chemistry. So we will be talking about this as well. Colors will mix, colors will flow. A lot of right guesses are actually coming in. I will be discussing the science behind this. The first experiment, the walking water experiment that we've done, I will be discussing all of these with you. Don't worry about this. Yes. So we will be waiting for that to happen. It takes some time for water to travel. You've guessed it right. You're halfway through. You've guessed it right that water will be traveling. But let's see what happens when it travels. Yeah. Hey, I was just going through the chat and capillary action. Somebody wrote about capillary action. Great. Awesome. Good to know that. Definitely, we will be coming back to the first experiment and we will be discussing the science behind walking water as well. First, I want you to actually observe what happens in this and then we would be talking about this. Water goes to the empty glass, Kushank says. Good to see that how excited you people are, how inquisitive, and most of you are making the right guesses also. Okay, let's move on to the next experiment, which is the milk rainbow. So let's switch the screen again and let's see what do we have to do in this. So this is something where you will be able to see the result instantly. So I have some food colors with me over here. I have the pink food color, I have the blue food color, I have the yellow food color, and I have liquid soap as well. And this beautiful glass in the center. You all know what this is. What is this? Quickly, let the chat box keep flowing. This way I'll also get to know how attentive you people are. So you've told me that you are super excited for the experiments. Let's see. Shweta is saying it's milk. A lot of you are saying it's milk. Alright, so let's put this milk in this glass. So this is like the first step that you have to do. Let's put this milk here. So I've emptied the glass. The milk is right there. Now let's do one thing. Let's add this food color in the center. How many drops do you want me to put? So I'll do as you tell me. I've taken the yellow food color. So I'll do as you tell me to do. 2 drops. 3. Okay, Aman says 3. Let me put 3 drops over here in the center. And there you go. I've put 3 drops over here. Next, I'm taking the pink food color. So I've put 3 drops over here as well. Next, I'm taking the blue food color. And let's go ahead. 1, 2, 3. Seems like a good pattern, right? Seems like a really good pattern. Now let's see what's going to happen over here. For this experiment, we would also be requiring earbuds. So we have it right with us, earbuds. Like I'm sure everybody is going to have it at home. So you require earbud. Dip this earbud in this liquid soap like this. I hope you all can see. And give me a count of 3. Let's put this in the milk and see what happens. All of you, some interesting emoji in the chat box, and then I'm going to put this. Let's see what's going to happen. I can see 3, 2, 1. I can see a lot of smiley faces. I can see thumbs up. I can see hearts, party faces. All right. So let's see what's going to happen now. Whoa! Did you see that? Amazing! So this is our milk rainbow. Great! How many of you like this experiment? I think this is a super cool experiment that you can perform at home. All the things are just easily available. Look at this spread. I mean, I can just play with this day in and day out. Amazing. Great, a lot of you are finding it to be super amazing. All right, let's switch to the first screen now. And yes, let's understand what just happened over here. So we had a plate, right? And in the plate, we had put some milk. We added some food colors. Then, when soap was being added, a beautiful pattern was being formed. What exactly happened? Can you guess? How did this milk rainbow actually get formed? So, I think some of you are making the right guess out there. Liquid soap that we have is actually a surfactant, which actually means that it reduces the surface tension. For those of you who are unaware of what this term means, surface tension basically is, it's basically a tendency that fluids have to occupy the minimum possible surface area. So initially, it was all, static at its place. Minimum area was being organized. It was taking the minimum area out there, right? The moment we added soap to it, what happened? The surface tension just decreased. And the wetting property, the expanding property just took place. It started just moving here and there. Surface tension, yes, correct. Isn't science really amazing? Isn't chemistry super amazing? So if you've liked this experiment, I want to see loads and loads of thumbs up in the comment section. Okay, some of you are saying you want to see the plate again. So let's, for once, quickly switch to the screen, and there you go. You can see the wonderful pattern out there. Okay, let's come back to the main screen. Great. How many of you are going to try this one? Let's see. How many of you are going to try this one? I see some me's coming. See, all you need is milk, liquid soap and any food color. Take any food color. A lot of you are going to try. Yeah, it's super amazing. See, you all are chemists. You just have to get that inquisitive side out, right? So get that side out and you will be able to solve a lot of experiments. Amazing, amazing. Yeah. All right. So we are done with the second experiment and now it's time to move on to the third experiment. And for the third experiment, we require some really basic things. Again, something that's completely available at your home. Okay, so we have purposely picked up all those substances जो आप easily arrange कर पाओ because we want all of you to, explore the science around, explore the magic of chemistry around. Definitely you can use that. Amazing. Good to know that. Okay, this experiment that we are going, I want you to tell me the science behind this. Because I really feel that many of you are super intelligent. You will be able to crack what's the logic behind this. Okay, you know what to do. Before starting any experiment, I want to see loads of smileys, loads of thumbs up. So that gives me a lot of energy to start now. So quickly, loads of smileys, loads of thumbs up, and then we move on to the next experiment. Don't worry, we will be back with the first one. I remember that. Good, I can see the smileys, I can see the thumbs up. I can see the happy faces and your happy faces. Your, the energy that you show over here, that makes us really happy. Alright, so let's move to the next one now. Let's switch screens and move to the next one. So, very basic things you see over here. There's a cup. This cup contains baking soda. You see some balloons out there and then you see there's a bottle. Any empty bottle you can take for this. Now, in this bottle, you will be putting vinegar. So, we will be putting vinegar in this and in the balloon. So, let's take a blue balloon. We will be putting baking soda. Now, this experiment that we are doing is called inflating balloon. So we've talked about working water, we've talked about milk rainbow, now it's time to see the inflating balloon. I can see some of you already guessed the reaction, this is super cool. That's why I said that this is the one where I want you to tell me the science behind this. So, we'll take this bottle, we'll take vinegar in this, we'll take a balloon, we'll put baking soda in this. And when this entire setup is being done, I'll quickly put this here. All right. So, I have put it over here and now yes, we can switch the screens because the setup is all set. So, we've got vinegar here and we've got a balloon containing baking soda. Let's see what's going to happen. Let's see how using a chemical reaction we can actually inflate a balloon. Isn't this super amazing? I hope all of you can see the balloon, right? Okay. Your smiley faces in the chat box and then I'm going to invert the balloon so that the baking soda reacts with vinegar. So your smiley faces are going to give me a good to go right now. Ahana has given a smiley face, so let's get started and let's see what's going to happen. We might want to move the camera a bit backwards so that they can see the reaction properly fine. Yeah, now the camera angle seems better. So there's a team helping us out here who are making sure that you can actually watch all the experiments in the perfect manner. So there you go, we've just inflated a balloon and the reaction is still going out. Hey, I hear the term, I can actually read the term effervescence that you've written over here. So there you go. This is our inflated balloon. Effervescence, I can see many of you writing about that. Prince found this experiment super amazing. Yes, and this is something you can do actually at your home. And you know, we all have science fairs. We have some science exhibitions, something related to science in our schools. Annual days are there. So many days are there where actually you have to exhibit something interesting in science. Some experiments are being performed. You can always use all these experiments out there and, you know, make everybody feel and realize the magic of chemistry that's around. So we had vinegar with us. Vinegar contains acetic acid and this balloon had baking soda. So the moment they both reacted, as you all are mentioning, carbon dioxide gas is being produced, and because of which we have our balloon that is inflated. You know, if I shake it a bit, more carbon dioxide is being released and the size of the balloon keeps increasing actually. Yeah, correct. Great, yes, I'm just trying to produce over here by mixing some more carbon dioxide. Alright, so how many of you are going to try this one? Let's see. If you're going to try this one, you know what to do. You have to post loads of thumbs up or write a me in the comment section so that I know that yes, you're going to perform this experiment. Yeah, there's a fizzing sound also. A lot of me, amazing guys. So good to read that. Yes. Alright, let's move on to the next experiment now. And for this next experiment, we require something really basic again. So we are constantly talking about all the things which are really basic. Correct, yes. Because we want you to perform this experiment at home. Yeah, that is the thing. See, science is all around, chemistry is all around. We keep telling you that. We are giving you ideas. How can you explore chemistry all around you? Okay, let's switch to the screen and see what's the next experiment we have. Hey, that's simple, right? We just need a glass for this. I think this is completely doable. And this is something that is going to be super amazing. Now, let's put vinegar in this glass. So, we have a glass over here. We are putting vinegar in this glass. All right. So, we've put vinegar over here. Sorted, right? I think 2 of the experiments require vinegar, so we are very sorted. Let's keep the second screen on so that they can see the entire experiment. All right. Now over here, we had a glass and we've added vinegar to it. Now, you just need an egg. And I'm sure you can guess the name of this experiment. It's Bouncy Egg. So, the next experiment that we have for you is Bouncy Egg, for which you need a glass, you need vinegar in the glass, and you need 1 egg. Some of you are guessing egg will float. Some of you are saying egg is going to bounce. Yeah, the name is Bouncy Egg. All right. Very carefully, I've put this out here. And hey, this looks like something super amazing. Let's zoom it a bit to see what's happening over here. Yeah, I can definitely see that some of you are writing comments on guessing this one absolutely right. See what's happening over here. We just had a glass. We had put vinegar in that and we've added an egg. Now, vinegar contains acetic acid. We just discussed this, right? And this egg that we have over here, that's made up of calcium carbonate. The outer shell is made up of calcium carbonate. Can you see some bubbles coming out? How many of you can see this? Let's see how many of you are able to spot the bubbles also. You can? Great. Because after some time, like after 1 day, if you will remove the egg from this, this is how the egg is going to look like. Let me put the original egg also so that you can compare. Can you see the difference? So this is how it looks. So we performed this experiment beforehand so that we can show you this bouncy egg. Now why are we calling this egg bouncy? Well, have a look over here. I'm able to press this egg. I'm not able to press this one. This is very rigid. But I'm able to press this one so easily. Yeah? And see, it's bouncing. I can't try with this one. It's bouncing also. Yeah. So, do you see the difference? All right. I hope you can see the difference between these two eggs. Let's get back to the main screen. Let me explain you what's the science behind this. Now, when we talk about this, vinegar contains acetic acid. We all know this by now. We've done enough experiments. Now, egg, as I told you, the outer layer contains calcium carbonate. So, when we add egg to vinegar, calcium carbonate actually, calcium gets dissolved in vinegar and carbonate is in a way moving on to produce carbon dioxide. And the bubbles that you suddenly start seeing is because of this carbon dioxide. So, the outer shell slowly gets decomposed. This outer shell slowly gets, it's breaking, it's getting decomposed. Now, the inner membrane that's there, that is super soft and flexible. And that's giving it that bouncy feel. But hey, when you try this at home, don't try to bounce it from at a greater height. It might just burst open because there are layers further inside this membrane also. But definitely you can touch, you can feel it that yes, it's squishy now. How many of you are going to perform this experiment with egg? Let's see. Hey Ajay, it was raw egg that we took. No, you need not take the boiled one. Go ahead with the raw one. Hey, I can see a lot of you writing me. Good to know that. Some of you are saying you're vegetarian and would not want to. You don't have to eat it, you just have to try this experiment. Yeah, it's like the shell being removed. Absolutely. Manisha is finding this experiment super amazing, and the best part is the science behind. If you understand it, I think half of the task is done then and there. Great. Yeah, definitely. I see a lot of green signals out there. Good. Okay. Now moving on to the next experiment. This is also a very super cool experiment that we have. Let's see if you all are ready for this or not. And for that, you have to give me a green signal again. See, I keep asking you for green signals. Let's see how many smiley faces are going to get. And then we'll have the entire setup ready with us for the next experiment that we have. This is going to be super amazing experiment, by the way. Yeah, I can see that. Good to know that. Hey Suhail, why are you upset? A lot of them are really excited for this one. Good. Thank you for giving me a good to go. Let's switch screen and let's see which is the next experiment that we have for you. All right, we'll have to zoom out a bit for this one because we have a bottle over here. And what do you need for all this? Let's see. So, first of all, we have a plate with us. Okay, we've taken a glass plate. We require some food color. So, I've taken red food color. Then we require a candle. So, I've put 3 candles over here. You can take any one. Of course, if there is candle, we would be requiring a matchstick. You require this bottle over here. I hope you can see the bottle now. We've taken a glass bottle. You require water. Another glass to make this solution. So, let's get started with the experiment now. Over here, we have a glass with us. In that glass, I'm adding some food color. So, let's make colored water first. Let's add some food color to this. All right. So, I've added some food color and now I'm adding water to this one. There you go. Our colored water is all set. I think I really like performing experiments with colors because every now and then there's something related to colors only. Let's just mix it properly. Awesome. How many of you also like performing experiments with colors? You do? High five right there. All right, we are done with this. But We still don't know what the experiment is, and I've not revealed the name of this experiment because I will reveal the name once the experiment is done. So this is ready, and now I'll just keep it aside. Okay. Let's do one thing. Let's light a candle now. So we have this candle over here with us. Let's light this. I want to stick this candle, so I'll just put it over here so that, you know, some wax goes down. Let some wax just melt a bit. Meanwhile, we can have the front screen ready with them. So you can have me on the front screen till we actually make this candle stand. All right. So we are just waiting for this candle to stick over here. We have to be really careful, right? Whenever there is something to do with candle, we have to be super amazing. Yeah, because we are burning a candle. So yes, we are setting it up. Wax is taking its sweet time to melt, you know. That's okay, because this experiment is worth it. It's super amazing, and you will be amazed to see the result. Okay, so we have, in a way, we are trying to stick it now. This reminds me of, so we have, you know, we have to switch off the AC and all because it's just blowing out, but that's okay. I think we've saved the best one for the last. Yeah. Hey, you've started guessing what's going to happen. That's super amazing. Yeah? Some of you are saying water will go up. Traveling water. Okay, let's see. Let's switch to the other screen and see what's going to happen. Yeah? So now we have this candle, thankfully, standing there, and we have colored water also with us. So I'm going to move this side a bit, and I'll just hold this candle so that it doesn't fall. Now, let's just pour this water all around. Yes, can you see this water? Keep giving me thumbs up, yeah. Keep giving me smileys. Some more? Okay, some more. All right. Okay, some more, but that's it. Some of you just, you know, you are already amazed to see water out there. But don't forget, we have this bottle with us. We have this bottle with us. Very careful. I'm going to invert this bottle. And slowly, we'll take the camera down with us. Don't worry. Let's take this inside. And there you go. The candle is still burning, but what's going to happen? Let's see, let's see. Oh, water just traveled up. How did the water come up? And why did the candle extinguish? What exactly happened over here? How many of you can guess that? I mean, the plate is almost vacant now. All the water is there in the bottle itself. So yes, as you people said, water is rising. The name of this experiment is correct. Yes, you people are right. Walking water, traveling water. Yes, you can name it any which ways. Okay, let's get back to the main screen now. Yeah. Hey, good to see the term out there, air pressure, because yes, that is the main funda behind this. Let me ask you, what do you think, why did the candle extinguish at the first place? So we'll break this experiment in bits. We'll try to understand this experiment in bits. Why did it break at the first place? What did you think happened? Air pressure. What? I'm asking about the candle being blown out. Why did the candle blow out? What do you think? Oxygen, yes, we require oxygen for burning, right? And there's a limited supply of oxygen in the bottle. So till the time oxygen is there, the candle is burning and the air around is it's heated up completely, right? Now, because of this heat, the particles start moving so fast and the air pressure increases. But the moment the oxygen is used up, the candle will blow out. Now suddenly the air gets cooled and it becomes compact. The air pressure goes down. Now this water that just went up, that is because of the difference in the air pressure inside and outside of this bottle. There's a difference in air pressure, right? In the inside and the outside of the bottle. Due to this difference, the water kept going up and it kept going up till the pressure was not equal. Awesome, guys. Good to know that. Yes, you can definitely make water walk at your home, in your mini lab also. Archana wants to see the first experiment. Yes, we are coming back to the first experiment. Let's have that setup of the first experiment as well. I know you people are super keen to see that. Yes, absolutely. Absolutely right. Yes, Mr. Bunny, I might not have seen your message, but it's good to know that you are right. Hey Ajay, whenever we are heating something, the air around us obviously it's heated, right? Because of this, the particles start moving really quick and the air pressure inside the bottle has increased now. But once the candle blows out, there's a sudden drop. The air suddenly cools and it compacts. So there is space out there, right? It's compacting. And at that time, when it's contracting, what is going to happen? The water quickly goes up because now the air pressure is really low inside the bottle and it'll keep going up till the pressure equalizes inside and outside. Anahita is super excited to see the first one. Okay, I'll reveal the first one. I have the setup ready with me. So we've spent some 30 minutes out there. You just need 30, in a way you just need 30 minutes to set this up and the result would be out really quick. So if you are also super excited to see the result of the first experiment, I want to see loads of smileys in the chat box right now. Let's see. Loads and loads of smileys, the ones who are super excited to have a look at the first experiment. Yeah, in a way, I agree with you. Walking water, traveling water, you can name it whichever way. That's your creative side thing. I can see loads and loads of smileys. So let's do one thing. Let's switch to the second screen and see what has actually happened over here. And there you go. I hope you all can see the second screen now, because over here we can see that now, as you people predicted, we have water in all the glasses. Correct. Yes, I hope you all can see that. Yes. Now you see over here a mixture of yellow and blue. Of course, blue is in a way dominating, but it's giving a shade of green as well out there. Similarly over here, you see yellow and pink merging. So water is in a way traveled. Yeah? Amazing. I see so many of you super excited. So colorful and beautiful, right? And you can actually perform all these experiments at home all by yourself. Okay, let's switch to the main screen and understand what has happened in this one. So over here, what did we have? We have water, right? So there are two processes that you need to understand the science behind this. That is cohesion and adhesion. Now, water is attracted to each other, right? It tries to stick to each other. But water is also attracted to the surface, other surfaces. In this case, what did we have? We had the paper towel with us. So this is what is adhesive force. Now because of this strong adhesive force, in fact stronger adhesive force I should say, water gets attracted to the paper towel. It keeps moving up even against gravity. I mean, this is amazing. It's just going up though gravity is trying to pull it down. Just imagine how strong this force is. And yes, I see a lot of you write about capillary action. Absolutely right. Based on capillary action. So yes, go explore more about capillary action also. Amazing. So out of these 5 experiments that we've shown you today, I want to know how many of you are super duper excited to perform all. And don't write you're a vegetarian. This is no reason not to perform the squishy egg, the bouncy egg experiment. Good, I can see a lot of you posting. Shivani is going to try. Anahita is going to try. Now see, now I'm reading your comments. So if you're going to try this, you can let me know in the comment section. Karthik's favorite subject is science. Apsara is going to try. Archana, Anahita, Sahil, Yajnesh, Ayush. Great, Rudrakshi, Nikita, Rama Devi, Aman, Santoshi, awesome. So many of you are going to try. Satya, Pratiksha, Sheetal, great. That's the purpose behind this entire session that we had, that you should explore the magic of science. There is so much to explore all around you. So we keep telling you, this subject is not limited to just your textbooks or just meant for exams. There is so much more to it. So we are giving you a direction, but now it's up to you to get that inquisitive side out and keep performing all these amazing experiments. Absolutely. A lot of exceptions are there in science. Great. All right. So if you've liked this session, quickly like this video also. And you can always let us know what kind of sessions you want us to come up with. And we'll keep coming back with the same type of sessions. So we do read your comments personally. Hey Anushka, Saurabh sir is about to take a session on that and you will be briefed about this really soon. Great. You've liked this video. Awesome. Good to read that. See, it feels really nice when you encourage us. Awesome, guys. You people were amazing. Thank you so much for being there. I had amazing time with all of you. I hope you also found the session informative. You also found the session interesting. And you're going to try all these. So, once you try all these, you can always come back and let us know in the comment section if this worked for you as well. All right, with this, it's time to sign off now. I can see you people are amazing. Great. Yes, definitely we'll do that. Awesome, guys. So keep exploring the magic of chemistry and we'll be back really soon. Until then, take care. Bye-bye.